My dear students, Brian, Ikia, Dolores, Tanya, and the rest, good afternoon. Yes, as you can see, this afternoon we have to continue with glaciers. And more precisely, we shall be looking at the erosional features of glaciers. The features produced when glacier is on the move, when glacier is eroding. When it does, it produces some features. And these are the features we have to look at them today. You call it features or you call it landforms. Landforms, features, they are the same thing. Now, the first we have to look at today is kuri. A kuri. You have different names, different appellations. You don't have to call it kuri. You can call it a sec. It's a Q. Or you call it a quant. Kuri, sec, or quants. These are the different names that pertain to a kuri. Now, on the board, we have the stages in the formation of a kuri. We have the stages in the formation of a kuri. You have stage A, stage B, stage C, and stage D. These are the stages. Now let me take you to the first stage A. What is it all about? What you should understand here is that a kuri begins as a shelter hollow. It begins as a shelter hollow. This is a hole. A shelter hollow where snow builds up. Where snow builds up. And remember that snow builds up most especially before the movement on a mountain, what we call mountain glacier. So a kuri is a hollow, a shelter hollow where snow builds up. So this diagram A is the first stage in the formation of a kuri. The first stage in the formation of a kuri. You see, here, the snow we compact. We have compartment of snow. Compartment of snow. You know, snow becomes so compacted that it becomes ice. It becomes ice. Now, as you can see, when the ice becomes so much, the ice is forced to start moving. Because it becomes so heavy that it can no longer support standing or on spot. So the ice start moving. Now look at diagram B. Diagram B, look at the surface is too rough because of the movement of the ice. Diagram B is rough because of the movement of the ice. Now, when the ice moves, there are actions that take place. Actions do take place during the movement of the ice. If you look at the board, this rough part of it tells you that plucking takes place. What is plucking? Plucking means that when the ice moves, it erodes. It erodes the materials along the path of movement. And then here you have weather weakened by freeze-thaw weathering. What do you understand by freeze-thaw weathering? Here would mean the melting of ice and the formation of ice. This continuous process, the melting of ice and the formation of ice, is called the freeze-thaw weathering. During the day, the water is turned into ice. It becomes hardy. And then during the day, the ice melts because of the heat that helps in melting the ice. At night, when there is no sunshine, there is a freeze action. So have this freeze and thaw action, which helps to do what? To break the path along which the ice moves. And remember, you only call it a glacier when it starts moving, because glacier means moving ice. Until when it melts and it starts moving, that is what we call glacier. So if you look at this second part, this diagram B, it is telling you that ice is already moving. The accumulation of ice is already moving. You have blocking takes place, rock weakened by freeze-thaw action, and then you have abrasion. What is abrasion? Abrasion simply means the collision. When the ice moves, as they are moving, they collide on each other, they break themselves and things like that into smaller particles. We say the ice is abrating. Now, this is it. Then diagram C is telling you that the hollow is being deepened. The hollow is being deepened because of the continuous action of ice movement. The hollow is being deepened. If you look at this diagram A, diagram B, you see diagram C now, the hole becomes enlarging and it becomes deepening. It tells you that the movement of ice is more apparent here in diagram C, and the actions too are more than the actions of diagram A and diagram B. Good. Now look at diagram C. Diagram C is just telling you that the areas have been eroded until, as the ice completely melts, you see a kuri clear. What did I say? A kuri is a sheltered hollow. So the ice there now has melted and become water. That's when you can see clear the formation of a kuri. And that water, which is found inside that hollow, is called a lake. And that lake has been given a name, a kuri lake. And most especially, or geographically, that lake is called a tan. That lake is called a tan. So one day, if you see this word tan, you should know it's a lake that is formed as a result of melting ice. As a result of melting ice in a hollow. And this hollow is what is known as a kuri. I am sure you have understood. Now, we have three of these erosional features produced by glacier. The first one we have just seen is kuri. In our next class, we shall look at arête. Arête. And the next, the third is pyramidal peak. In our next class, we shall look at these two features, these two landforms that are produced by glacier. So that is it for today. And if you go to your book on page 69, you will see what I am struggling to explain to you. That a kuri is a sheltered hollow which is filled with ice, which is filled with snow. And when the snow becomes so compacted, it is now called ice. And when the ice has been so much has built up, it can no longer stand on its own, so it is forced to move. What prevents it to move? Since the ice is so compacted, there is heat in between. So this heat will make the ice to melt. And when it starts melting, now the ice will start moving now down the slope. As it is moving, that is what we call a glacier. As it moves, it is now called a glacier because glacier is moving ice. Now, diagram B tells you as it is moving, processes are taking place like blocking, like abrasion, and then the weakened rocks. The rocks are weakened by the freeze and thaw wedging. What is wedging? If I want to tell you, wedging is the disintegration or the breakdown of rock particles by forces of weather. When I talk of forces of weather, I mean rainfall and sunshine. So, rock weakened by freeze-thaw wedging. So you should know what wedging is. And we have physical wedging, we have mechanical wedging, we have biological wedging, and so on and so forth. So all of these different kinds of wedging help to disintegrate or to make the movement or the part on which this snow goes to be very rough. Then, continuous process deepens the hollow, and after some time, the water now, the ice completely melts, and as it does melt, you see a kuri which is formed completely, which is a hollow, as you can see in diagram D. I am sure there is nothing you have to doubt about this, because remember I told you in class. So this is the formation of a kuri. In our next class, we shall go to arête and complete it in pyramidal peaks. If you have any question, please, you have our lines, you have my private line, you have the group line, the group page. You can ask a question, and please go to page 69 or in your book and read more and understand for yourself, and you ask meaningful questions. So, in the absence of any question for today, let us call it a day until we meet again.